Welcome back, students. In this video, we will try to understand the pattern of reciprocal based problems. Till the last video, we covered some 5 patterns of problems. This will be the 6th pattern what we are going to discuss. So, just for record, we have completed the theory part wherever there's a tick mark. We have completed the board problems wherever there's a tick mark. Right now, we are dealing with the board or sample problems related to zeros and coefficients of quadratic equations. If you landed on this video directly, and if you have not earlier seen this part 7 and part 9, kindly review these 2 videos for better understanding of this video. So the problem pattern looks something like this. You are given alpha as one of the 0 and its reciprocal 1 by alpha as another 0. This is very much a board problem. It has not quite often appeared, but here and there I can see some problems. But the good thing is this is the most simplest pattern, actually, most simplest pattern. So we'll understand how to do it. So as I told you, this is the pattern 6, reciprocal zeros, where they give 1 0 of the polynomial and the other is the reciprocal. And most likely you need to find the constant term, which will be k or a or something. You need to find out that. So the example problem is polynomial 3x square plus 8x plus k, and 1 0 is the reciprocal of the other. You need to find the value of k. So before we start with the problem, let us understand a few basics or the solution approach. The quadratic polynomials have 2 zeros, alpha and beta. In this pattern of problems, you have 1 0 as the reciprocal of the other. So in a case where you have 2 zeros, alpha and beta, then since 1 is the reciprocal of the other, you can write beta as 1 by alpha. So to make you more clear in numerical terms, so let us assume that 3 is one of the zeros of the polynomial. Then the other 0 is its reciprocal, that is 1 by 3. So the easiest way to solve this problem, where 1 is the reciprocal of the other, it is chart with the product of the zeros, because 1 0 is alpha and the other is its reciprocal 1 by alpha, their product is always 1. So this is the most quick trick or tip which you should hit upon. So in this problem, the value of k or the unknown you need to find out is in the constant term, which is again the position or the part of the equation which forms the product of the zeros. So this is why I have shaded in blues. This is not necessarily the case, but most of the times you need to find out something related to the constant term of the polynomial. So the first example, we'll go back to the example what we saw first. So you put a mention that one of the 0 is alpha and the other 0 is its reciprocal 1 by alpha, and the product of the 0 is alpha into 1 by alpha is equal to 1. Now you need to find out the product of the 0 from the quadratic equation. From the quadratic equation, if to find the product of the zeros, it is c by a, where the coefficient as c is k, a is 3, so it is k by 3. Now you need to equate the product of the zeros that you get from the quadratic equation and the product of the zeros that you arrive by multiplying alpha into 1 by alpha is equal to 1. So you are going to equate this and this. So k by 3 is equal to 1, which gives the value of k as 3. So option A, 3 is the right answer. So we will see one more example. So the equation is 2x square minus 3x plus k, and they have mentioned that one of the 0 is the reciprocal of the other, and find the value of k. So as usual, you need to mention this too very clearly. Say that you are going to assume one of the zeros alpha and its reciprocal is 1 by alpha, and the product of the zeros is alpha into 1 by alpha is equal to 1. This has to clearly come out in your first 2 statements. Then you need to find the product of the zeros from the equation. Maybe you can mention here the product of zeros from the quadratic equation. You can mention that way. I think the previous problem I have mentioned, but here I missed it. So you have to mention from the quadratic equation, you have the product of 0 as it is c by a. It's again here, it is k by 2. Now you are going to equate both k by 2 and 1. You are going to equate both and find the value of k as 2. So let me take you through problem 3. I wish that you solve this by yourself, and I'm going to give a couple of seconds for you to attempt this. Then I'll take you through the solution. Okay, let me move to the solution part. If you want to try, you can just pause the video, try, and then get back to the next slide. So, same as I told you, let alpha and 1 by alpha are the zeros. Product of the alpha is 1. And from the equation, the product of zeros from the equation, please note this entire thing is C. Entire thing is C. So, it becomes minus k by 2 divided by the value of A, that is 6. So, that you are going to equate to 1 what you got from the earlier product of the 0 alpha into 1 by alpha. So now rearranging and solving, you get the value of k is equal to minus 4. So in the next video, I think that would be the probably the last pattern what we'll be discussing, after which we'll go through some more problems. So bye till we catch again. Thank you.